For information security managers, the hardest operational hurdle is rarely spotting a threat. The real challenge is bridging the persistent chasm between abstractly identifying that threat and concretely deploying a mechanism to stop it. This gap is where most compliance architectures fail. Organizations treat risk and defense as disconnected silos, throwing an amorphous cloud of risk at a rigid wall of controls and hoping something catches. Without a formal mechanism to translate a vulnerability into a specific defense, organizations default to reactive patching. They chase symptoms instead of building a systematic defense. The Information Security Management System, or ISMS, acts as the structural framework for organizing these disparate efforts into a unified process. Reliability comes from building a verifiable mechanical pipeline that forces a specific defensive action for every identified risk. The ISO 27001 framework functions as an interconnected architecture designed to close the gap between risk and control. This graphic diagrams that architecture. The title states the thesis: From Risks to Controls, the Interconnected Architecture of an Information Security Management System. The subtitle untangles the relationship between three components: ISO 27001, Annex A, and the Statement of Applicability, or SOA. A common error in the industry is treating the main standard and Annex A as identical documents. This leads organizations into blind, checklist-based compliance, implementing controls without context. True compliance is achieved when these three components operate together as an active, cybernetic loop, rather than as isolated checklists. To see how this loop functions, we have to start with the core standard itself, Clauses 4 through 10 of ISO 27001. These clauses do not contain technical controls. They establish the management framework required to operate the entire system. You can visualize this management framework as the active engine of the ISMS. Within this engine, Clause 6 for planning and Clause 8 for operation act as the specific mechanisms that mandate formal risk assessments. The operational purpose of this engine is straightforward: to generate a comprehensive, validated list of unacceptable risks that the organization is required to treat. The main standard functions as the discovery engine, mapping the entire environment to identify exactly what needs securing. Once those risks are generated, that data stream needs a destination. It needs specific control frameworks to mitigate the identified threats. This is the role of Annex A, specifically the updated 2022 standard, which serves as the standardized catalog for these controls. We can visualize Annex A as a highly structured repository, sitting on the opposite side of our architectural blueprint. The modern 2022 structure categorizes these controls into 4 clear themes: organizational, people, physical, and technological. It is crucial to understand that Annex A is a menu of options. Attempting to implement every single control in that vault blindly, without justification, is an architectural failure. If the main standard is the engine identifying problems, Annex A is merely the hardware store containing the potential tools to fix them. Looking at the blueprint, there is an obvious spatial gap remaining between the risk engine's output and the Annex A vault. The Statement of Applicability, or SOA, is the structural bridge mandated to span this exact gap. The SOA carries a rigorous legal requirement. It must list every single control in Annex A and explicitly state whether it is applied or excluded. You cannot simply check a box marking a control as applied. The SOA must mathematically link the selection of that control back to a specific risk identified by the engine. Exclusions demand equal rigor. You must justify exactly why a specific tool in the vault is unnecessary for your organization's unique environment. The Statement of Applicability ensures an organization is not guessing at security. It transforms abstract risks into a deliberate, defensible architecture. To see how an auditor evaluates this architecture in practice, let's trace a concrete technical example through the complete 3-pillar system. Imagine the organization's risk assessment engine identifies unauthorized remote access as an unacceptable risk. That specific risk output travels into the SOA matrix to find a required mitigation. The matrix processes the threat and routes it to the exact necessary tool within the 2022 technological theme, Control 8.2, which governs privileged access rights. Based on this precise mapping, the IT department is now formally mandated to deploy multi-factor authentication for all remote administrators. Without the SOA acting as the router, deploying MFA is an arbitrary IT project. With the SOA, it becomes a mathematically justified, auditable defense. The final misconception to clear is that the SOA is a static spreadsheet, generated once a year solely to satisfy an auditor. Consider what happens during a disruptive event. A new zero-day vulnerability is announced, or the company suddenly shifts to a fully remote workforce. The architecture automatically responds. The new threat triggers the Clause 8 operations engine, which analyzes the data and outputs an updated risk profile. This new risk profile flows directly into the SOA, forcing a recalculation. Controls in Annex A that were previously marked as excluded might now be immediately toggled to applied. The interconnected architecture operates as a cybernetic feedback loop. It constantly senses danger in the environment and automatically adjusts its defenses in real time. The main standard mandates risk discovery. Annex A provides the raw materials, and the SOA builds the house. Information security managers must stop treating these three elements as isolated compliance chores. Mastering ISO 27001 is entirely dependent on mastering the translation bridge between them. True security architecture depends entirely on the unbreakable logical links connecting every single defense back to a validated risk.